All right, so with this one, what we want to do is, since these top and bottoms are parallel, I'm just going to kind of focus my attention on those parallel lines. So maybe I highlight them or color them, however. Those are parallel, right? Would you consider that line there a transversal? That kind of makes sense? So if I do that, it's actually, these lines are a little bit ridiculous in their size.
I missed half of the problems. I didn't know how to do it. I didn't do good on it.
All right, so if I look at those, we've got 4x up here, and then x minus 10 down here, right? Now I'm going to, just because I think it makes things a little bit easier, if I get rid of the picture in the background, does that make it a little bit easier to see that those two angles are same?
So like they equal 180.
Right, so we're going to add those together and set them equal to 180. So then we'll say, so one equation ends up being 4x plus, is that a x plus 10, x minus 10. So x minus 10 is equal to 180. And then for the same reason, we can solve that for x. I'll leave that up to you. But we come over here and do the same thing. And does it make that one and that one same side interior as well?
Okay, that makes sense.
So we'll go 3y plus 12 equals 180.
I did that in my head. I didn't know that's how you should do it.
And then that's the earlier in the day, and we can go over if you want to, but there was a question, I don't know if I still got it up here. This one here. And, people struggled with trying to find maybe one variable right off the bat and say, I'm going to focus and force myself to find y. Well, if I look at this.
Is this the one I got wrong? Is it the only one I got wrong?
I got like 3 parts of that.
If I look at maybe that line right there and that line right there being parallel, and I cut them with that transversal, right? So we got y there and y there. Now if I take the picture out of the background, what kind of angles are those?
Acute.
Well, they might be acute.
It's like alternate interior.
Right. If I extend the lines beyond what they're defined as, and I get that generic picture that looks kind of like that every time, right? Y and Y are alternate interior. But there's no, it'd be nice if this was like 90 right here, or 85 or something like that. And we're going to say, well, Y is 85. But now it's just saying Y is Y. That's the relationship. They're equal. So there's nothing I can gain from looking directly at Y and trying to solve for Y first. So the next thing you do is look at maybe a different transversal. All right, so I look at that transversal there. Okay, and looking at the components, W is there and 19 is there. Bring the picture out. Now you can make the argument that W is 19, right? Yeah. Because they're alternate interior again. And what happens is that people want to look at this picture kind of holistically and think about the whole thing at once, and there's just so much going on that gets confusing, right? Redraw the picture, maybe grab some crayons or highlighters or markers or whatever and highlight things to focus and narrow your attention. But maybe I look at, there's a varying amount of techniques you could probably use here, but let's say that I want to continue looking at those parallel lines and look now at maybe that transversal. Okay, so if this was W up here, but now we know it to be 19, right?
Yeah.
So isn't that angle there going to be 42 plus 19? So that'll be 61. And this angle here is going to be X plus Y, right? Okay, so now if I take the image out of the background, this was X plus Y here. So now can I say 61 plus X plus Y equals what?
180.
180. Okay, now that equation really doesn't get me what X and Y is, right? It doesn't really get me down to one value for those things, but what it does do is later on when I go through and try to find maybe what X is, once I find X, can I come back to this equation and find Y? Yeah, or vice versa, if I find Y and come back and find X. But looking at those two parallel lines, I've kind of exhausted maybe, I guess except for this one, maybe look at that transversal and see if we can learn anything from that.
Biggest question.
Okay, go ahead.
I don't get how you use the 61 and X more than 180.
Because when we
Yeah, it is a lot.
look at them this way, because this angle, you understand why this is x plus y, right?
Yeah.
That's the angle addition. And this one was an angle created by 42 degrees and 19 degrees, so I add those together. That's why I get the 61.
Yeah.
But those two angles, if we go back to our kind of generic format for parallel lines cut by transversal,
The same side interior.
yeah, that angle there and that angle there, which this one here would be the 61 and this would be the x plus y. They are same side interior, so they're supplementary.
Would you like to go in there and try to get that last question to get 100%?
Yep, too late. So that's why we can set those equal to 180. And the idea is maybe another way of approaching this is to think that this red angle here is going to be the same as that angle up there, isn't it? Does that make sense? Because they're corresponding. Okay. So if I transfer that x plus y there, x plus y and 61, do they create a line now? They create that blue line. So you've got a linear pair there. So that's maybe another way of getting the idea of why those two angles are supplementary, is because I can transfer either that x plus y up, or I could transfer that angle there and that angle there are corresponding. So transfer the 61 here, and now we see that those two are a linear pair. So that is a fact that those two things should be added up to 180. Looking back to this, okay, maybe I can set up the equation that now y plus 88, okay, plus now that of 19 plus v, okay, again, if I move the picture out, those two angles are same side interior, so they should be supplementary. So I get that equation as well. Okay, now I could, if I had enough algebra, if I had enough equations that had x and y in it, I could solve using the system. If I had another equation that had y and v in it, I could solve using the system equation. But I don't have those things yet. But what I do know is those things to be true. They are facts. So I write them down because they might, in the end, be useful for me. Okay, I might come back and use them again later on. So let's clean some stuff up here, because I think I've exhausted all my transversals for those two parallel lines. So I have another set of parallel lines. They're the ones on the left and right. So if I look at that parallel line, and now maybe use that transversal, okay? If I look at that angle right there, would you agree that should be the same as that one right there?
Yeah.
Because they're what kind of angles?
Interior.
Yeah, they're alternate interior angles, so they should be the same. And if one is 42,
The other one's 42.
the other one's 42. So now, what's nice about that is now I know V is 42, right?
Yeah.
Well, V is 42. Can you replace that 42 right there?
No. Yeah.
Yeah, so now I have Y plus 88 plus 19
Plus 42.
plus 42
I'm up, you get.
is equal to 180. Okay, I'm going to leave the addition and subtraction here for you to do, but will that solve for Y?
Yeah.
That'll give me Y to be some number, right?
Yeah.
Can I take that number of Y, come back up into that equation,
Find X.
plug that number in for Y, and that will leave me an equation with just X in it. I can solve for X, right?
Well, we know X already.
Okay. Oh, we didn't find X yet. It is what, though?
88.
It is 88, because looking at maybe, and that might be an easier way than using those equations, but those equations will work. Maybe you look at that transversal, and you know that and that are alternate interior, and that might get you X a little bit quicker. But using this approach, you should be able to replicate that 88. And that's the thing about a lot of times in geometry, we're going to see problems that,